I am Shanile Godal, and I'm here to discuss about the amplitude modulation and the FCC emission designations.
Hello, I'm James Edward M. Reyes. I'm going to discuss about AM spectrum, power calculations, power spectrum, important facts about AM, voltage and current calculations, and simultaneous modulation.
Good day, I'm Regina Diloy and I will be discussing amplitude modulation, modulation index, and classification according to the degree of modulation.
My name is Joshua Labo and I am going to discuss the problems regarding modulation.
I'm Tamia B. Perido, and I'm here to discuss about the problems related to amplitude modulations, modulation index, its effective modulation index, its total transmitted power, and the bandwidth.
Amplitude modulation. What is modulation? It is the process of altering a characteristic of the carrier in accordance with the instantaneous value of the intelligence signal. It is the process of varying one or more properties of a periodic waveform called the carrier signal with a modulating signal which typically contains information to be transmitted. The characteristics of the carrier that can be varied are amplitude, frequency, and phase. The modulation is the process of recovering the intelligence signal from a modulated carrier signal. It is the act of extracting the original information-bearing signal from a modulated carrier wave. Consider a sine wave carrier. Mathematically, small e sub c is equal to e sub c times sine quantity of omega sub c times t plus theta, where small e sub c is the instantaneous carrier amplitude, e sub c is the peak carrier amplitude, omega sub c is the carrier region frequency, which is equal to 2 pi f sub c, and that f sub c is the carrier frequency, and theta, which is the carrier phase. Reason for modulation. First is for minimizing interference. Second is for frequency assignment. Third is for making antenna sizes practical. And lastly, for multiplexing. FCC emission designations. An emission designator is a code associated with the frequency that gives information about the frequency's bandwidth and the nature of the signal on the frequency. The code consists of a 4-character bandwidth code followed by 3 symbols. This is the FCC emission designation. Given that the first symbol signifies the type of modulation of the main carrier, second symbol which signifies the nature of the modulation, and the third symbol which signifies the type of information being transmitted.
Commonly for transmitting information via a radio carrier wave. AM works by varying the strength of the transmitted signal in relation to the information being sent. The trace of the peaks in the AM wave is called the envelope, which has the same shape as the modulating signal. Mathematically, the instantaneous value of the AM signal is E sub AM is equal to A sine omega sub c times t. The expression is composed of 3 signals: the carrier, lower sideband, and upper sideband. Modulation index. The term that describes the amount of amplitude change in an AM waveform is called the index of modulation. It is also called coefficient of modulation, modulation factor, or modulation depth. M is equal to E sub m over E sub c. This graph shows that Vmax is equal to E sub c plus E sub m, and Vmin is equal to E sub c minus E sub m. Thus, the modulation index can be expressed as E sub m over E sub c, or Vmax minus Vmin all over Vmax plus Vmin, and the percentage of modulation is modulation index times 100%. Classification according to the degree of modulation. Under modulation, where m is less than 1 and E sub m is less than E sub c. Over modulation, where m is greater than 1 and Em is greater than E sub c. And lastly, perfect modulation, where m is equal to 1 and E sub m is equal.
Here we can see the graph for the AM spectrum. If it's f sub c minus f sub m, it is a lower sideband. If it's f sub c only, it's equals to E sub c, which means peak voltage of the unmodulated carrier. If it's f sub c plus f sub m, it will become a upper sideband. Here we can see the formula for bandwidth for the AM. Bandwidth is equals to 2 times f sub m. Next is the power calculations. First, for the formula for the unmodulated carrier power, or P sub c. P sub c is equals to V sub c sub RMS squared over R, or E sub c squared over 2R. Next is the lower sideband power and the upper sideband power. For the lower sideband power, V sub LSB sub RMS squared over R. For the upper sideband power, it is P sub c m squared over 4. Next is the total transmitted power, or P sub D. P sub D is equals to P sub C plus P sub LSB plus P sub USB, or P sub T times 1 plus m squared over 2. Here is the power spectrum. As we can see, here is the graph for the power spectrum. If it is f sub c minus f sub m, it will become a lower sideband, which is equal to P sub c times m squared over 4. If it is only f sub c, it will become a P sub c that is equal to E sub c over 2R. If it's f sub c plus f sub m, it will be a upper sideband, which is equal to P sub c times m squared over 4. Here we can see the percent power formula. Percent P sub c is equals to P sub c over P sub d, or percent P sub sb is equals to P sub sb over Pt. Here's an important facts regarding about AM. Among the three signals comprising AM, only the sidebands contains the information. The information found in the upper sideband is identical with the lower one. At 100% modulation, only 66.67% of the total power is contained in the carrier and only 33.33% is in the sidebands. Thus, it is wasteful to transmit the carrier and is redundant to transmit both sidebands. Here is the formula for the voltage and current calculations. For the peak voltage of the modulated carrier, or E sub t, it is equal to E sub c times the square root of 1 plus m squared over 2. For the peak current of the modulated carrier, or E sub t, is equals to E sub c times the square root of 1 plus m squared over 2. Lastly, this is a simultaneous modulation. Here we can see the graph for the simultaneous modulation. If it's f sub c minus f sub m f sub c minus f sub m 3, it is m sub 3 times E sub c over 2. If it's f sub c minus f sub m 2, it is m sub 2 times E sub c over 2. If it's f sub c minus f sub m1, it is f sub 1 times E sub c over 2. If it's only f sub c, it is E sub C. If it's F sub C plus F sub M1, it is F sub 1 times E sub C over 2. If it is F sub C plus F sub M2, it will become a M sub 2 times E sub C over 2. If it's F sub C plus F sub M3, it is M sub 3 times E sub C over 2. Here's the formula for the bandwidth. It is 2 times F sub F 2 times F sub M sub N. Lastly, here's the effective modulation index formula. M sub t is equal to the square root of f sub 1 squared plus m sub 2 squared plus m sub 3 squared, and so on and so forth.
So for problem number 9, an AM broadcast station operates at its maximum allowed total output of 50 kilowatts and an 85% modulation. How much of the transmitted power contains the intelligence? So to compute for the percent quantity 1 plus the modulation index squared over 2. And for the unmodulated carrier power, you can also use 50,000 as it is converted to watts from 50 kilowatts over 1 plus 0.85 squared over 2. So we got 36,730.945 watts for the unmodulated carrier power. So looking for the difference between 50,000 minus 36,730.945, we got 26.538%. For problem 11, for an AM DSB-FC transmitter with an unmodulated carrier power of 500 watts that is modulated simultaneously by 4 tones, which is M sub 1 equals 0.1, M sub 2 equals 0.2, M sub 3 equals to 0.4, and lastly M sub 4 equals to 0.5. Determine the total modulation index, the total sideband power, and the total transmitted power. To look for the total modulation index, just simply add the 4 tones, square each one of them, and then take the square root of the result, just like so. So we got 0.678. So to look for the next one, which is the total sideband power, what we do is multiply m sub 2 squared, which is 0.678 squared multiplied to 500 over 2. The result is 114.921 watts. And for part C, we add the total sideband power and the unmodulated carrier power, which is 500 plus 114.921, in which the result is 614.921 watts. For problem 13, an AM transmitter has a carrier voltage of 50 volts at a carrier frequency of 10 MHz. It is modulated by a 75% by a 1 kHz sine wave. What is the total RMS voltage transmitted? So the E sub t equals to E sub e multiplied by the square root of 1 plus the modulation index squared over 2. The E sub c equals to E sub RMS multiplied to square root of 2, or which is 50 multiplied to square root of 2, and we got 70.71 volts. And to compute for E sub t, what we do is multiply 70.71 by the square root of 1 plus quantity 0.75 squared over 2, and we got 80.04 volts. To compute for the E sub RMS, voltage is equal to E sub t over square root of 2, which is equal to 80.04 over square root of 2, and the result is 56.596 volts. And lastly, problem 15, a certain transmitter radiates 9 kilowatts when the carrier is unmodulated and 10.75 kilowatts when modulated. If another sine wave corresponding to 30% modulation is transmitted simultaneously, what is the percent change of the total power? To look for P sub t, it is equals to P sub t times quantity 1 plus m sub 1 squared over 2. Compute for m sub 1, it is square root of 2 multiplied by quantity 10.75 multiplied by 10.75 times 10 raised to 3 over 9 times 10 raised to 3 minus 1. And we got 0.6236. M sub 2, which is 0.3. And to look for M sub t, it is equals to the square root of 0.6236 squared plus 0.3 squared. The result is 0.692. To look for P sub t, it is equal to 9 times 10 raised to 3 times quantity 1 plus 0.692 squared over 2. The result is 11.155 kilowatts.
For problem number 1, we have what is the modulation index for an AM having Vmax and Vmin of 2.6 volts and 0.29 volts respectively. We all know that the formula for modulation index is M is equals to E sub M over E sub C, where E sub M is equals to Vmax minus Vmin, while E sub C is equals to Vmax plus Vmin. Substituting the values, we'll have 2.6 minus 0.29 all over 2.6 plus 0.29. Computing for the values, we'll get 0.7993 as our modulation index. Problem number 3. Determine the bandwidth of an AM signal modulated by a 5 kHz tone. Given the formula, bandwidth of an AM is equals to 2 times f sub m, where f sub m is equals to 5 times 10 raised to 3. We'll have a value of 10 kHz as our bandwidth. Problem number 5. An AM transmitter is modulated by two audio tones at 1 kHz and 2.5 kHz with the modulation depths of 0.25 and 0.5 respectively. Find the effective modulation index. The effective modulation index formula is m sub t is equals to square root of m sub 1 squared plus m sub 2 squared. Substituting the values, we'll have 0.559 as our effective modulation index.